show the solution for 7.37a, and in this video in this problem we have that the amount of time that Americans watched TV in 2015 had a distribution where the mean minutes per day was 168 minutes. So that means true mean is 168 minutes. And it has a standard deviation of 20 minutes. So there's our sigma. And we're supposed to find the probability that when we take a sample of 400, that we will get between 165.7 and up to 167 minutes for our sample outcome. So we're using the central limit theorem. Our sample is well above 30. So we go ahead and realize that our X bar follows a normal distribution where the middle matches the true mean. And the standard deviation for X bar comes from sigma over square root of n, which is 20 over square root of 400. We're supposed to find the chance our sample is between 165.7, so let's say 165.7, and 167. So that's between these ranges. So notice it's really important that we are clear on which side of the mean these fall so that we're finding the correct area. So when I'm going to solve this, I need to convert each place to a z-score. So I'm going to have z1 that goes with the bottom value and z2 that goes with the top value, and this is also the area between. So again, what I'm thinking about is if I take a sample of 400 people, that after I calculate their average amount of time watching TV, the answers that I get would land from my one sample. My answer would land between 165.7 minutes and 167 minutes. So Z1 comes from X bar minus mu over sigma over square root of n. And this is the X bar that I'm using is the first one, which is 165.7 minus mu of 168. Sigma is 20 over square root of 400, and I will get a negative 2.3. So that's Z1. Z2 I'll do in a different color. Z2 is going to go with the 167 minutes. So Z2 will be, if the sample had a mean of 167 minutes, the true mean stays the same, the standard deviation and the sample size stay the same, and that's going to turn out to be -1. So now I have two z-scores, and I need to find the area between them. So when I first look up a -2.3, that will tell me the size of my left tail right there. And the size of that left tail is 0.0107. So yellow, well, I'll write it over here because it goes with this z-score. Yellow is 0.0107, which, remember, that means the chance that the sample mean was below 165.7 it also means the chance that Z is less than negative 2.3. And then let's figure out yellow plus stripe is the area all the way to the left of Z2. That area is 0.1587. So this means the chance the X bar is less than 167, which is the same as Z turns out below a negative 1.0. But that 0.1587 includes the yellow area, and I don't want the yellow area for my final answer. So the final answer that Z turns out between Z1 and Z2 is the same as the sample turns out between 165.7 and 167 is going to come from 0.1587, pulling out that yellow tail, and I'll get a final answer of 0.0. Sorry, the difference between those two is going to give me 0.1480. So the probability a sample of 400 Americans will show that the whole sample average is between 165.7 minutes and 167 minutes is a 14.8% chance. Remember, this is not the chance that an individual American will be watching TV between that amount of time. This is the chance that the sample average of 400 Americans turns out between those.